Hello, welcome to freshgrad.com and you are watching Network and Security Training Program, Day 3, TCP IP. So what is TCP IP? TCP IP is a transmission control protocol and internet protocol. That's what it stands for. TCP IP stands for Transmission Control Protocol and Internet Protocol. Is a set of rules used to send and receive data over the internet or a private network. Is a set of rules. TCP IP is a set of rules used to send and receive data over the internet or a private network. Think of TCP IP as the language of the internet. Okay, it's a language of the internet. It ensures the computer understands and communicate with each other. Simple example, imagine you are sending a letter like a data, right? A simple mail letter to a friend in another city, or like think about it as a computer, right? So TCP ensures the letter is properly packed and delivered in order, right? So it's properly packed in the envelope and it's delivered by the mailman to your friend in another city. And IP finds the best route to deliver the letter, right? So what is IP in the internet stands for is best route to deliver the letter. So similar way, if you send it to the FedEx or DHL or any other like a UPS or any other USPS, any other postal service, right? They will find the better route to deliver the letter to the destination. Okay. And TCP, this model is another way to look at the overall data transport, and it also uses layer to illustrate the process. And let's take a look at the history of the TCP IP. TCP IP was developed by USA Department of Defense (DoD) in late 1960s and is still widely being used in the internet and everywhere. Okay, in 1975, two network IP communication test was performed between Stanford University and College London. In November 1977, a three network IP test was conducted between sites in the US, UK, and Norway. Several other IP prototypes were developed at multiple research centers between 1978 and 1983. Okay. Now, as you see, TCP IP is a little bit different, right? We learn about OSI model concept. OSI has a 7 layer and TCP IP has a 4 layer. The first layer is application. That's where is the data. Layer 3 is the transport layer. Again, segments. We'll in the next slide we'll just compare OSI versus TCP IP. Okay, and internet layer has a packets, and the network access layer that one has a beats. So the TCP IP has only 4 layers. It removed three other layers. If you remember the OSI, right? So it's a presentation layer, session layer. It's removed here, and the data link layer also got renamed. It's not here in physical access layer. So we'll compare it with the OSI model in a bit. But let's right now deep dive into each layer, right? Again, TCP model has a 4 layers, each with a specific job. So think of it like a sending package through a delivery service, right? Application layer is a user interaction. So what is the role of the application layer even in the OSI and TCP IP? Basically, it's user interaction. This is where applications like web browser, email clients, right, interact with this network. Okay, this is where uh, the user interact with this network. Okay, for an example, HTTP, uh, the web, right? When you access any web browser, this is the example of uh, the application layer. In file transfer protocol, FTP, that's an example of the application layer. SMTP, it's when you send an email, email user SMTP. Okay, simple mail transport protocol. That's used by email. So another example, when you type google.com into browser, right, that's a HTTP request and TCP IP handles the connection. So TCP IP, this is the model. Okay. This model TCP IP handles the connection to how you gonna access the google.com. And now the transport layer. So what is the role of the transport layer? Transport layers gives you reliable delivery. Okay. This is the transport layer. Transport layer will give you reliable delivery. So ensures the reliable data transfer between device using the TCP or UDP. Okay. There's another protocol, TCP or UDP. Uh, Soon we'll deep dive into TCP and UDP and we will compare it. Just right now, get yourself familiar with these terms, right? So transport layer ensure reliable data transfer between devices using the TCP or UDP. TCP reliable but slower. TCP is a reliable but slower. We'll compare it in the next slide. And then UDP is a faster but no compromise like a regular letter. So for an example, if you are streaming a video, right? Or if you're streaming a video on a youtube.com, UDP sends chunks of data without waiting for confirmation. That's where it's used the UDP. So there is no guarantee, right? And if you're downloading any file, that's time the TCP is being used, TCP. So ensures all part of the files arrive correctly and in order, right? Now let's take a look of the next layer, internet, right? This is where the segments get converted into the packets, okay? And data get converted into segments at the network layer. So internet layer, um, this is where the IP addressing, if you remember at the network layer, the IP addressing. So this is something misleading part here, but we'll compare it, right? Where you use the IP address in the TCP IP and where you use the MAC address in the TCP IP layers, right? So TCP internet layer, this is the responsible for finding the best route to deliver packets using the IP address. Okay. So path determination and IP logical addressing. Okay. So this is the layer is responsible for finding the best route to deliver packets using the IP addresses. And the main protocol is being used is the IP addressing internet protocol. That's a logical addressing, IPv4, right? We looked at it, what are the ranges of the IPv4. But we'll deep dive into the IPv4 in the next one or two lectures, okay? And this is like your GPS, right? If you're using a Google map, so this is like a GPS guiding a car to the destination using a street address. And similar way in the internet, IP guides data packets to the correct destination using the IP addresses. And the next layer is the network access. This is the layer one, right? So network access layer is a physical transmission. This is where MAC addresses handles. MAC address is also known as a physical address or and switches are the example of here the MAC addresses. So the network layer, right? This is the network layer handles sending data over the actual network hardware via cables or Wi-Fi, right? It can use any cables. We'll discuss the cables as well in the next few sessions. Okay. So think of this as a delivery truck physically carrying your package to its final destination. Have you seen the FedEx truck, right? Or any UPS truck or any DHL trucks, right? Those are the trucks, right? Or if you see at your home when you request a package, Amazon truck comes, right? So those trucks, right? Think of those trucks are physically carrying your package to your final destination. So now let's take a look at the comparison of the TCP IP and OSI model. So now if you remember, right, OSI model has a 7 layers and it's also known as a 7 layers, right? Open system interconnection. An application layer, these 3 layers data remains as a data in the data format, right? application layer, presentation layer, and session layer. These are the three layers where data call simply call data. And once data reach at the transport layer, it will get converted into segments. And once those segments reach at the network layer, layer 3, it get converted into the packets. And the packets simply get converted into the frames at the data link layer, and then it get converted into bits 0 and 1, right? And media signals and binary transmission happens. So now if we simply compare with the TCP IP model, what the TCP IP model they merged this three layer into one layer, application layer. And then transport layer remain the same. If you see here, transport layer remain the same. And the network layer, this is where is the IP addressing, right? So in the OSI model, it's called the network layer, but in the TCP IP, it's called the internet layer. That's a layer 2. And again, those last two layers, they merge into one network access. So this is the comparison. Okay. It's very important to understand the OSI model and TCP IP, memorize it. When we talk about the IP addresses, right, you should know like, hey, in the OSI model, it's as a network layer, layer 3. And in the TCP IP model, IP address is at the layer 2, internet layer. It's very important, okay? And the MAC addresses are here, resides in the data link layer, layer 2. But in the TCP IP, it's at the network access layer, okay? So it's very important to remember this all concept throughout your career, right? Even when you're working as a network engineer or troubleshooting, it's very important to understand these layers, and it's very important to know all this and memorize this. Now let's take a again deep dive into the each layer of the TCP IP. So application layer. So application layer interacts directly with the end user applications and provides the network services directly to the user. And the application layer is a combination of three OSI layer as we saw in the comparison diagram, right? Layer 7 application, presentation, and layer 5 session layers. And it handles data formatting to ensure that data is presented in a readable format. So all three features, right, or OSI models layer 7, layer 6, and layer 5, all those three layers of the OSI models features happen at uh, layer 4, the application layer in the TCP IP. And data encryption, decryption happens at this layer. So now if you look at the examples, right, email protocols, SMTP and POP3 are the perfect example of the application layer. Layer 4 in the TCP IP, Telnet, HTTPS, when you do web browsing, SMTP, uh, simple network management protocol as well. Now we are talking about the transport layer. So transport layer, there are a lot of things to understand in the transport layer. Okay. So end-to-end communications and provides the error-free delivery of the data. The transport layer end-to-end communication and provides the error-free delivery of the data. And two protocols are operated at this layer. What are the two protocols? TCP and UDP. TCP is a transmission control protocol and UDP is a user datagram protocol. So TCP guaranteed delivery, right? And it's reliable and it ensures the data arrives intact. And TCP basically detect the error via sequence and acknowledge numbers. We'll look into the next slides how TCP detects the errors and how it recovers. Okay, we'll look into it in a few minutes. And windowing feature. Okay, we'll look into the windowing feature as well. And TCP is a connection oriented. We'll look into it how it is connection oriented. And TCP is a slower due to the acknowledgement checks, right? TCP does acknowledgement checks. That's why it's a little bit slower compared to the UDP protocol. And if you look at the examples, right, TCP, when you download the files or if you send in emails or if you're web browsing, those are the perfect example of the TCP. And now let's deep dive into UDP, user datagram protocol, right? So user datagram protocol is the best effort delivery, but no guarantee of the delivery, right? They will put their best effort to delivery, but no guarantee of the delivery. It's not reliable. It sends data without the checks or acknowledgements, right? It doesn't acknowledge. When it's sent, it sends, whether it get delivered to the destination or not. So simply sometimes, right, you might have faced that issues when you send a postcard to your family members, like, if you are wishing birthday postcard or anniversary postcard or any festivals postcards, right? Those postcards, it's not high priority of the mailman to deliver it. Why? Because it's very cheapest, right? So they will put the best effort to deliver it, but they won't give guaranteed like okay it will get delivered, right? There are many times you get lost your postcard when you call and ask them like they never receive those postcards. So that's why there is no error detection in this and no windowing feature, and it's a connectionless. Okay. But it is a faster because it doesn't wait for responses. It doesn't wait for the acknowledgement or responses. That's why it's a faster. And if we look into the examples, it's a video streaming or online gaming or voice over IP, like a voice phone. Now transport layer, we still continue it here, right? Let's deep dive into what is a TCP three-way handshake. So with the TCP, there is a work to be done before data is transmitted, right? The two devices have to agree on the basic parameters before segments can be sent. And this negotiation has the curious name three-way handshakes, okay, in other language. So like a two person, right? Even if the two humans are talking to each other, they agree on it, right? Like, hey, are we going to speak and communicate in what language, right? We are going to communicate in English, or we are going to communicate in Hindi, or we are going to communicate in the French or Spanish or any other language, right? So it's similar way, computer first. Uh, those two devices need to agree on some basic parameters. Now let's look into it. Now if you see here, server A and server B, right? So three-way handshake, like you may have heard the first time, but you are probably wondering how a handshake can be three-way, right? But in the computer language, it's a three-way handshake, right? As a human, we do handshake with the only two hands, right? But in the computer, there's the three-way handshake. And let's take a look at it. So before the sender can start sending the data, there is going to be negotiation between two devices, the server A and server B. There will be some negotiation uh, regarding the rules for data transmission, like how they are going to data transmit. And that negotiation is a three-way handshake itself, which begins with the sender transmitting TCP segment with this synchronization bit set. Okay, so that's begin with the first step. This is the first step. The server A send a sync bit set synchronization. Sync stand for synchronization. Bit says, and the primary value being negotiated here is the TCP sequence number. There will be sequence number, we'll look into it, right? And that sequence number, so that's a sequence number they will send it. We'll look into it. And the recipient responds, now the server B, right? The server A send the sync signals and the server B received it. And what server B, if the server B receives it, and simply acknowledge like, hey, yeah, I receive your synchronization bit. So it's called sync ACK. ACK stand for acknowledgement. And this is the part of the two of the three-way handshakes, right? So one and two-way handshake is done. But now server A will again respond like, hey, yeah, I acknowledge that you received my synchronization signal. Okay. And this is called three-way handshake. So again, before the sender can start sending the data, there's going to be negotiation between two devices regarding the rules for data transmission. That negotiation is a three-way handshake itself, which begins with the sender transmitting the TCP segment with the synchronization bit set, the sync signal right here. And the primary value being negotiated here is the TCP sequence number. And we'll deep dive into TCP sequence number. The recipient responds with the TCP segments with the both like synchronization and acknowledgement right here. That's called TCP sync. This is a part of the two-way handshake. And then server A again responds with back with the acknowledgement. And this is the part of the three-way handshake. And remember, UDP does not use a three-way handshake. Okay, UDP doesn't use this three-way handshake. And that's why there is no guarantee of the data delivery. But TCP used the three-way handshake. This is how, like synchronization, sync, act, and acknowledge. These are the three-way handshake. Okay, and that's why TCP has a guaranteed delivery. Now let's look into it how, like next thing, let's look into it if, right, TCP connection termination, how the TCP connection termination works, right? So TCP connection termination works on the four-way handshake. Again, you'll be surprised, like, yeah, if they want to build a connection, it's happen on the three-way. But if they want to terminate, then it happens in the four-way handshakes. How? So either the server, right, the server A or server B, right? Either server can initiate the termination. So for an example, server A is active close. Why? Because it sends a finish signal to the server B and bring the channel down, right? It set the finish means like, hey, now I'm done. I don't need to communicate with you. Let's bring the channel down. The communication is close, right? So firstly, from the one side, the connection either from the client or the server, the fin flag will be set as a request for the termination of the connection, right? So in this example, server A send the fin X to server B, and server B receive the finish signals. So what it simply does, it simply respond back with the acknowledgement number plus uh, FCS. This is the sequence number. It's increment the sequence number by one and then send it back to the server A. Like, hey, yeah, I received your finish signal. And then what happened? Again, server B will send a finish signal. Like, hey, I terminated your signals. Now I'm sending you finish signal to server A. And then server A responds back with the acknowledgement to server B. And then finally, the TCP connection terminate. So this is why it takes a four away handshakes, right? So this is the termination. So these are the two important concepts, right? TCP, how TCP2 devices, build a connection. That's called three-way handshakes. And if the TCP connection termination is also known as a four-way handshake. So these are the two important terms you need to remember. Three-way handshake and four-way handshake. These are also interview questions. many interviewer will ask this question, what is the three-way handshakes and four-way handshake? So you should definitely understand this and know this. Okay, it's very important. So this is very important. Okay. And now let's look at this, the next topic. So next topic is again we are still in the transport layer. This transport layer is not done. TCP errors detection and error recovery. So how the TCP does the error detection and error recovery? Let's take a look here. Right. Error detection and error recovery are not the same thing. Again, remember that error detection and error recovery are not the same thing. So error detection is finding an error, right? What is error detection? Is a finding an error. If you anywhere, right? Like if you find an issue in your assignment or somewhere, right? So that's you found an error, right? So it's error detection. And what is the error recovery? Is doing something about the error, like how you resolve it, right? How you fix that error. So it's error recovery, how you can recover it. So here, TCP does both, and it uses both sequence number and acknowledge number in the TCP header to do so. So in this above example, like one host is sending four segments to another host, right? If you see here, sequence, this is the random sequence number, okay? So when two computer or server or any two devices, they communicate with each other, they will use the random sequence number. I'm just taking an example. This is the sequence order for easy to understand here. Let's take an example. It's like 100, 200, 300, and 400. But remember, this is a random, okay? They might pick any number, okay? But this is for us. It's easy to understand. So that's why I took this for 100, 200, and 300, and 400. So server A sends four uh, sequence to server B. And this each segment has a sequence number. So this segment has a sequence number of 100, right? And this segment has a sequence number 200. And this segment has a number of 300. And this segment has a number of 400. Now, for simplicity, uh, we assume that these are the four sequence number like 100, and we'll add up like with the 100, right? So it's easy to understand 100, 200, 300, and 400. And these are all, remember, oh, again, I told you, right? Segment. These are all the segments 100, 200, 300, and 400 because we are the transport layer. And what happened at the transport layer? Segments, right? So data gets converted into segments. Layer 4 in the TCP is the data because it's application layer. And at the transport layer, it get converted into segments. So remember this. Okay, so as you see, this is still TCP error detection and error recovery. So now what happened, right? Server A and server B. So server A sends four segments, sequence number with a random sequence number, but I just assume here 100, 200, 300, 400. And what server B will do? Server B responds back with the incremental of this, the last segments. So it's increment by 100 or it increment by 1 or whatever the random number it is, right? And it sends an acknowledge to server A like, hey, I receive your signals. So the recipient will now like send an acknowledgement, right? So the natural question here is like, why is the acknowledge number set that way, right? Because that's how TCP detects lost segments. And what if the second segment didn't get the recipient? right? So what happened if the second segment did not get delivered? So now just let me bring it. So what server B will do? So server B will respond back with the hey, stop. It will respond server B. What server B will do? Server B will say like, hey, stop. I didn't receive the sequence number 200. And then what simply server B will do? Server B will simply send an acknowledge 200, right? Because it did not receive the sequence number 200, right? So it simply sends to server A with the set the acknowledge number 200. And now what the server A will do? Sim it's simple. This is where we detect the error, right? Because this is error detect, right? So when server A sends four segments to the server B, but the server B did not receive the sequence number 200, right? And this is how we detect the error because simply server B sends an acknowledge number with set the 200, like hey, and then server A get to know that like hey, server B did not receive the segment with the sequence number 200. So let me resend it. And this is where the error detection happens, right? This is called the error detection. So when the data sender sees that acknowledge number, it knows that the segment with the sequence number 200. So this segment did not get delivered to the server B, right? So that's the error detection part of this process. And what is the error recovery now? Data sender server A will simply resend it. It will simply resend this segment with the sequence number 200. And this is called error recovery. All right. So error detection and an error recovery. So once again, server simply sends the four segments to the server B, but server B says like, hey, stop. I did not receive the segment which has a sequence number 200. So server B will do, it will send an acknowledge number with the 200. So now server A knows that the server B did not receive this one segment which is with the sequence number 200 random sequence. So that's called error detection, right? And now to fix that error, server A will retransmit it again. Okay, it retransmit again to the server B, and that's called error recovery. And now the data recipient has all the segments, right? So now the server B has all segments sequence number 100, 200, 300, and 400. So now server B will says like, hey, I have four the segments, right? And then it will increment by one. Okay, it will increment by one to the acknowledged number with the 500 and send it to the server A. So now the server A knows that like, hey, the data was successfully delivered and server B has all the four segments which I sent. But again, remember, UDP does not use the sequence number. UDP does not use the sequence number. So how does UDP works? UDP just sends the data and says like, hey, I don't care about the acknowledgement. I don't care uh, whether it gets delivered or not, right? So you don't, the sender doesn't know. So in other words, simple like a mailman, right? Like TCP is like when you do the register mail or you ask FedEx and then you ask them like, hey, when you deliver it to the destination to your friend, make sure he signs it, right? Because it's very important. And if they sign it, and you get to know that your friend received it because you can see your friend's signature. So this is the your signature is like an acknowledgement number here. So now we are done with the error detection and error recovery. So what happens if the acknowledgement is lost or positive acknowledgement with the retransmission? What is the PAR? Positive acknowledgement with the retransmission. There is always a chance that segments are arriving, but acknowledgement the acknowledgement of those segments somehow get lost. And we certainly don't want our data sender just sitting there and doing nothing while waiting for an acknowledgement. Okay. So let's take in again example of the server A and server B, right? So server A sends four segments with a random sequence number. Each segment has a random sequence number 100, 200, 300, and 400, right? And now the server A will stop and wait. Why? When the data sender transmits the segment, it sets an acknowledgement timer. I'm just giving an example, right? Once it sends four packets, it will wait for like a some timer, right? It's gonna be milliseconds. We don't even know, right? Everything happens in a milli or nanosecond. It's pretty fast. Mm, You not even have 1 second. Okay. So it sets the timer, right? If the timer expires and no acknowledgement is received, right? For example, to take it, right, there's a 10-second timer, right? So clock is ticking 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Done, right? What will happen? Now server A says like, hey, I didn't receive any acknowledgement from the server B. So I'm not sure whether he received those four segments. So what server A will do? Server A will retransmit those four segments again. Okay. Why? Because the acknowledgement of the 500 got lost somewhere. So that's why server A will retransmit those again. And this entire process resolves around two things. The sender is waiting for a positive message from the recipient that data was received. If that message isn't received, the data is retransmitted. Simple, right? If the data, if the acknowledgement is not received within the timer, set of the timer, right? There is a timer. It could, I'm just giving an example. If the 10-second timer, if the time's up, then simple, the server will retransmit the data. And that's why we call the entire process positive acknowledgement with the retransmission, PAR. So it's very simple and easy. So continuing, like now let's understand the TCP windowing feature we talked when we compare TCP versus UDP, right? So at the beginning, right, we previous example data sender transmitted four segments as you saw, right? Now let me bring that diagram again here, right? So it sends four segments. These are the segments. Segment 1, 2, 3, and 4. So now for an example, we assume that each data segment, this segment is a 600 bytes in the size, right? This one has a 600 bytes, 600, 600, and 600. So total data is 2400. So now the server A send the four segments to the server B, right? And each segment has a 600 bytes in the data. Now, windowing refers to the amount of the data the data sender is allowed to transmit without waiting for an acknowledgement. Okay. So now this is the data, right? The sender can transmit without waiting for the acknowledgement. So this is the example, right? So the sender can send the 2400 bytes of the data before it wait for the acknowledgement. And now the sender will send an acknowledge recipient will send an acknowledgement number 500 and sender will receive it. So this is the windowing feature. But how we get to decide this windowing feature? Let's take a look. So data recipient, So here, data recipient get to decide what is the windowing size. Okay. In the previous example you saw, we took a 2400 bytes, right? But what if the server B doesn't have that capacity to collect the 2400s of the bytes data at the same time, right? In that case, server B decide, recipient, always the recipient decides like what is the windowing size. The, so server B says like, hey, the size of the windows is 1000 bytes, right? If the data recipient sees that there is no error occurring with the window size, the recipient will increase the size of the window in from 1000 to 1500. And it says like, hey, now the size of the windows is 1500 bytes. So the server A will send a 1500 bytes. It can be in 15 different segments, each segment with the 100 bytes, or like a three segments, each segment with the 500 bytes, or either way. Okay. The sender will send the data at the same time of the 1500 bytes. And now what happened? The server B says as the window size increases, some errors are going to creep in, most likely drop the segment as the recipient's buffer fills, right? So now server B has increased from 1000 to 1500 and server B is facing some issues. The recipient will dynamically adjust the window size downward. So now it will set higher than 1000 but less than 1500. Okay. So the windowing size would be higher than 1000 new size, right? But less than 1500. So the sender will say like, hey, the new size of the window is now 1200 bytes. Now send me the 1200 bytes of the data at the same time. So the sender A will send the 1200 bytes of the data. And the data recipients reduce it to right 1200 and data recipient says that now there is no issue, right? So in that case, the server will decide like, hey, there is no issue in the 1200 bytes, so we'll keep it at the 1200 bytes. So each time the server A will send a, bytes to the server B with the 1200 bytes, right? For an example, A and B. So it will send a 4 bytes. Each segment will have a 300 bytes. Total 1200 bytes, right? And then server B will send an acknowledgement number, acknowledge it. And then what happened? Server A again sends with the 4 segments with the same 1200 bytes of the data. So this process continues because now the server B has decided that, hey, this is my capacity. My capacity is a 1200 bytes, right? I can receive the 1200 bytes without any errors. So server always recipient gets to decide, right? What is the windowing size? So now why do we use the UDP if TCP is so great, right? All of the features we looked at here, the three-way handshakes, windowing, sequence, numbering, right? Error detection and recovery are all TCP features. Okay. If someone asks you three-way handshakes or termination, TCP connection termination happen as a four-way. So remember that. Okay. TCP three-way handshakes, four-way handshakes like TCP terminations, windowing, sequence numbering, error detection and recovery. These are very important features of the TCP IP. And UDP doesn't use any of that. So two question comes in my mind, like why doesn't UDP offer those features, right? And why in the world do we use the UDP for anything? So let's take a look at here. In the Let's compare TCP versus UDP. right? So this is a TCP segment here, and this is a UDP datagram header. So what are the common things you can see here? One common thing we can find is a source port in both, right? Second is a destination port. We'll look into the ports, right? What are the different types of ports, TCP ports and UDP ports. We'll look into it, okay? But right now, just get yourself familiar with these terms, right? And what is the other thing if you find here? Check some. So TCP and UDP headers have only three values common: source port, destination port, and checksum. If you don't know what ports are, soon we'll find out, right? So will you know what are the ports, how to use it, and by end of this training program, you will be expert like what are the ports. And so now we answered the question about why UDP doesn't offer the feature that TCP does, because in TCP UDP's header doesn't have those features, right? It doesn't have this windowing size, pointer, or sequence number acknowledge. It doesn't have these features, right? In the UDP. So now when you're studying, take your time on TCP and UDP, compare it, right? Transport layer. So what are the common ports of the transport layer right here? File transfer protocol uses the TCP port 20 and 21. Okay, these are the important ports. Okay, there are so many ports, but if you remember, these ports are more than enough in the industry. Okay, secure cell port, SSH port. This is a port 22. Telnet port is a port 23, and this is the secure port. Remember with the name itself. Okay, and SMTP, Simple Mail Transfer Protocol, user TCP port 20, HTTP user port 80, uh, POP3 user TCP port 110, HTTPS when you browser, right, and you see some lock sign in it, or green lock sign, right? Why? Because they have a valid certificate and they are using the port 443. Some of the common UDP ports, DHCP. DHCP, Dynamic Host Control Protocol. We'll deep dive into DHCP. What is DHCP later? UDP ports use the 60, port 67 and 68. TFTP, Trivial File Transfer Protocol, use the UDP port 69. Protocols using the both TCP and UDP ports, DNS, um, domain name service. We'll look into DNS as well, the concept. Use a UDP and TCP 53. The port number 24 is reserved in the both UDP and TCP, so port number 24 is not being used. Some of the interviewer might ask like, hey, what is the HTTPS port TCP, right? 443. Or they can ask you like 443 is a UDP port or TCP port, right? So it's a TCP port. So you just need to remember only these ports. That's it. There are many other ports. The ports range start from this, but we'll deep dive into it when we learn the IP addressing. So there are two sets of protocols that are occasionally confused with each other. So let's draw a clear line between the following: SNMP and SMTP. So these are the simple network uh, protocol and simple mail transfer protocol. Okay. So this is a simple network management protocol and simple. This is the uh, mail transfer protocol and NNTP and NTP. Again, so these are the protocols you need to remember. Network News Transfer Protocol, this is called, and NTP is a network time protocol. So each server in your Windows servers, right, you will see the clock, right, in your Windows machine or a MacBook, or if you are familiar with the Linux machine, right, they have a time. And why? It's because of the NTP, Network Time Protocol. So these are the again important protocols concept. So just remember that NTP is widely being used. SNMP is also being used. SMTP is being used. Now let's take a look. We know the internet layer, right? At the internet layer, what happened? IP addressing or logical addressing. So internet layer is a concerned with the logical addressing, routing and forwarding data between the different networks. And it provides logical addressing such as IPv4, IPv6, determine the optimal path for data to travel from source to destinations, right? Again, it's determine the optimal path. So if you are sitting in the New York City and San Francisco, right? You are sending an email to your friend. The router and in this layer, internet layer, will decide which is the optimal path. There might be two or three ways to reach to San Francisco, right? One, you go North Carolina, Georgia, Atlanta, and then you go San Francisco. When you go on the top, right, uh, Chicago, and then you go on upstate, and then you go down to San Francisco. There might be some third way as well. But who will decide? At internet layer, right? IP addressing. They will determine which is the optimal path to get here, right? If the roads are better in this route, the data will be sent to this route. If this is the best route and fastest way, right, and the data will be sent to this route. If this is the fastest way and best, then data can be sent through this route. Okay. And again, network access layer is a physical access. Okay, some MAC address or physical addresses are at the network access layer, like a connections, right? Cables. Cables are like a Cat 5, Cat 6. These are the mostly being used in our home or day-to-day use. But there are other Cat cables as well, Cat 7, Cat 8. So protocol of the link layer operates within the scope of the local network connection to which host is attached, right? And the and the next is a network topology, how data flow works. If we already looked in the OSI model, like how data communicates, right? So here in the simple process, once device A or host A sends the data, how it go, it's traveled from application to transport, transport to internet, internet to link layer, or this is the called network layer. Network and link are same, okay, because you are using cables here, and then it goes to the Ethernet cable or Wi-Fi cable. It will go up, right? And similar process. The data comes down here, and then it goes back to up. And the transport layer, this is a host to host and connection oriented, right? So it's guaranteed the data, and the process to process happen at the application layer. So now you know what is the TCP IP, what are the use of the TCP IP, three-way handshake, TCP termination, right? TCP connection termination, or it's called also four-way. The sequence number, error detection and error recovery, those are the very important concept. Okay. Thank you.